Hello and welcome to Section 2 of Module 1, The Big Picture. In this section, we'll be answering the question, why build neurotechnology? The first and most important reason to build neurotechnology is to treat neurological disorders. It's important you understand why this is the most important reason because of these statistics. In 2016, neurological disorders caused approximately 9 million deaths worldwide. And they were the second leading cause of death after cardiovascular disease. On the right, we have a pie chart that indicates the distribution of global deaths due to neurological disorders. As you can see, stroke and Alzheimer's disease are the two leading causes. This is a slide from Neurolink's progress update in summer 2020. Neurolink is a neurotech startup that was founded in 2015. Despite all the hype around the long-term implications of their technology, they've made it very clear that the first purpose of their device is to treat and cure neurological disorders. Here are 3 examples of disorders. Number 1 is Parkinson's, number 2 is Alzheimer's, and number 3 is epilepsy. Parkinson's is marked by nerve cell damage to the substantia nigra. Cells in that region produce the neurotransmitter dopamine, and dopamine is responsible for regulating movement. One way to treat Parkinson's is deep brain stimulation. How this works is you place thin wires into the brain that send electrical impulses to the basal ganglia to control your motor impulses. Alzheimer's kills neural pathways in brain cells, and its main symptoms are memory loss and confusion. There are 3 neuroimaging techniques we've discussed earlier that can be used to detect and diagnose Alzheimer's: MRI, CT, and PET. There is a treatment, transcranial electromagnetic treatment, TEMT, that non-invasively slows the progression of Alzheimer's. However, this isn't a cure. Lastly, epilepsy is marked by sudden recurrent episodes of sensory disturbance and excessive brain cell activity. EEG, electroencephalography, which we've talked about earlier, is the go-to technology to diagnose epilepsy. Doctors can use EEG to look for wave abnormalities. The most popular treatment for epilepsy is vagus nerve stimulation, or VNS. It's a device that sits under the chest and electrically stimulates the vagus nerve in the neck. Again, this isn't a cure. Stroke rehabilitation is a major area where neurotechnology can help. As we saw earlier, stroke is the leading cause of death among all neurological disorders. In fact, every 40 seconds, someone in the US has a stroke, and every 4 minutes, someone dies of a stroke. Stroke is also the leading cause of long-term motor deficits and mobility reduction. Today, a nurse often has to walk a patient through stroke rehabilitation. However, nurse availability is a limiting factor, and it's difficult to scale stroke rehabilitation if you're dependent on nurses. A promising neurotech solution is motor imagery. This works by asking the stroke patient to imagine certain movements, such as clenching their fist. We can detect these imagined movements in EEG signals and use those detected movements to provide visual and mechanical feedback. For example, if the patient imagines clenching their fist, then on the screen we can display a cartoon hand clenching its fist. The brain thinks the movement is actually being executed. Motor imagery is taking advantage of the brain's plasticity. In summary, neurotechnology first and foremost is needed to treat neurological disorders. Although we can diagnose and treat certain disorders, we're unable to discover causes and permanent cures for others. Stroke is the most common neurological disorder, and motor imagery is a promising neurotech solution to improve, speed up, and scale stroke rehabilitation. In the next lesson, we'll be covering a second reason for building neurotechnology, and that's to understand the brain.